Hi everyone, I'm Baihan Lin from Columbia University. I'm presenting my work, Online Semi-Supervised Learning in Contextual Bandits with Episodic Reward. In the online learning setting, the agent or the contextual bandit usually receives the context and makes a decision based on it. Then, an expert or user would give a feedback to the agent as a reward, which will then be used to update the agent. The bandit feedback can either be a positive reward or a negative reward. However, more often than usual in real life, the feedback could be missing. In another word, the rewards usually comes in episodes of different frequencies. This is especially true in many real-world applications. For instance, in a recommendation system, the user might be sticking on a product page for a long time because he or she is away from the computer, and this inactivity shouldn't be treated as negative feedback to this product. In personalized medicine or longitudinal studies, some patients might stop showing up for follow-up checkup or drop out of the study. This missing data point shouldn't be treated as negative data point as if they passed away or otherwise. In many interactive systems these days, the system learns continually through interacting with the users. However, when the users are not around giving feedback, the system shouldn't interpret it as a positive or negative signal. In on and off seasons, the feedback to certain advertisements will come in different frequencies, but that shouldn't be treated the same way as if some ads are more popular than the others. We can formulate this problem as the contextual bandits with episodic reward. For each round, the agent makes a choice given the information from a context X. However, the reward feedback R for its chosen action is only revealed in an episodic fashion. In this work, we model the episodic reward as a probability P from 0 to 1, suggesting the probability this feedback being revealed to the agent. To solve this problem, we proposed a solution based on the standard linear upper confidence bound algorithm, which we call Background Episodically Rewarded LinUCB, or BerlinUCB. The major difference between BerlinUCB and LinUCB is at the episodes where no feedback is given. We use two strategies in such a case. We either only update the covariance matrices, or we create a pseudo-reward from some sort of self-supervision mechanism which enables us to update the agent as if there is a reward. Under the proximity assumption, we chose our self-supervision modules to be three online clustering algorithms: Gaussian mixture model, K-means, and K-nearest neighbors. We empirically evaluate the performance of our algorithms and the standard LinUCB algorithm in the online classification task with bandit feedback. We chose MNIST and Wolfram as our dataset and generated 6 synthetic non-stationary environments. We created non-stationary contexts either by varying cluster distribution over different episodes or inversing the images into negative images. We create non-stationary reward either by shuffling class labels over different episodes or switching between MNIST and Wolfram classification tasks over different episodes as a multitask environment. We also consider the case where the number of arms is fixed and known from an oracle. The alternative would be the contextual bandit doesn't know the number of arms, and it extends its arm during the learning when facing new classes. Lastly, we vary the frequencies of the reward revealing over different episodes. Shown here are the average classification accuracy in these experiments. It is important to note that the classification with bandit feedback is far more challenging than the traditional classification problem, because the bandit feedback only reveals whether the prediction is correct, but it doesn't tell the agent which arm is in fact the right arm. We see that both the stationary case and in the case of non-stationary oracles, our methods demonstrated a clear advantage over the baseline, even in the extreme case where only 1% of the reward is revealed. In the scenarios of the non-stationary context and rewards, we still observed an overall benefit of our proposed method over the baseline. We also provided a proof of concept in an application of online speaker recognition task. We consider this interactive system that receives a continuous stream of audio input from a conversation of multiple people. The system would output in real time the name of the person who is currently speaking, and it learns from the user that tells it whether it makes a correct prediction or not. However, as we can see, the reward is very sporadic, because the input stream and the prediction are continuously provided without interruption, but our user won't be there providing feedback 24/7. We evaluated on the Minivox benchmark and demonstrate a robust performance over the baseline. If you are interested in this specific application, feel free to check out the extended version of this application referenced below. In conclusion, we proposed a novel problem setting inspired from practical online learning application called Contextual Bandit with Episodic Reward. We consider it as an online semi-supervised learning problem and proposed a novel solution that introduced self-supervision to provide pseudo-feedbacks to the agent in episodes without feedbacks. To evaluate the performance of our algorithm in this setting, we introduced a novel non-stationary benchmark that includes 6 types of synthetic stationarities in context, reward, and oracle. From the experiments, we observed that updating the representation structure when no reward is revealed improved performance of contextual bandits. Adaptive learning with context-dependent clustering modules is much better than learning without self-supervision. Ongoing directions include improving the self-supervision modules, for instance with graph method, incorporating the online clustering module into the online learning problem itself, providing the theoretical work of this problem, and extending it to more applications. Thank you for your interest. If you have any question, feel free to reach out to me. You can also check out several of our related work in this direction, which are referenced here. The full paper can be accessed on arXiv, and the codes are available at our GitHub repository. Thank you.